want to show you the working principle of inverter, how inverter work, how you can manually do it, the full working principle of inverter, how you can assemble it mechanically, just how to do mechanical inverter, to understand the principle of converting direct current to alternating current, the flowing of direct current, the flowing of alternating current. Through this experiment, you will understand it in full details. Let's go and see. Keep watching. Today, I want to show you the easiest way to understand how inverter work. In this experiment, I will demonstrate the system inverter converts DC current to AC current. So in this experiment, you can see this is our storage device. Battery ni agbesibi, transformer re, this is transformer, bulb re, this is bulb. It's already connected to the secondary winding of this transformer, you can see, and this is the primary winding of the transformer. The primary winding is 14 volts. It's 14 volts. This is our 220 volts bulb. The bulb is 220 volts. So now, this is the demonstration. You can see by keeping on vibrating this one as fast as it can go, you can see automatically the DC current has passed through the primary winding. Transformer step it up to 220 volts. That's why I can light up this bulb. So if I'm not vibrating it, the bulb will just shake. See, you can see the bulb is off because I'm not shaking it. So if I do it like this, see how it is. So, but if I keep on vibrating it, if I can do this like 60 times within a second, the bulb will not shake. The bulb will light permanently. So that is the way DC current is being converted to AC current. So now, that is why the manufacturer designed transistor IC, which is a MOSFET or IGBT, to act as the electric switch that will automatically on it, off it, on it, off it, on it, off it. That will keep on doing this. That is the work of MOSFET and IGBT. That's what they did. As they keep on, DC currents go in a straight form, as MOSFET continue acting as electric switch, on-in it, off-in it, on-in it, off-in it. So as it continue waving it, it turn it to current that go in sinusoidal wave. So now I want to use this relay to represent MOSFET. So you can see the demonstration I just did. So now, this is the original MOSFET designed by the manufacturer of inverter. So that is why they use this MOSFET. That's why this MOSFET is used. This MOSFET is used to act as electric switch, so that the MOSFET will be the one doing this thing. This reaction will be carried out by MOSFET. So if you understand the working principle of MOSFET very well, you will know that MOSFET is an electric switch. It auto on, auto off, auto on, auto off to make the DC current that go in direct way, that make them to call it direct current, to become sinusoidal wave currents that go in sinusoidal direction, that go in alternating form. So that's why. So now I want to use this relay to represent MOSFET. This will act as electric switch that will be helping us to join it, helping us to off it, helping us to connect it, helping us to off it. So this relay will do that. Actually, you already know that relay, coil, any relay that is even 220 volts. This is the cover. This is 120 amps 120 amps relay. The coil is 220 volts AC. Manufacturer designed this to accept 220 volts AC input. You can see those are the diode inside the relay coil, and you can see the relay coil. You can see the relay coil. So the two conductor connected to it is the one that will carry alternating currents from the source. The alternating current will pass through the diode before going through the coil to energize the coil, to make the coil turn to electromagnet, to flip the pin of the relay. Basically, you have seen the construction of the relay coil. So now let us assemble it back. This is the iron that will suck the magnetism, and this one was constructed to hold down the coil, in the relay mechanism. After assembling the coil back, you tight it from the back to hold back the coil. You can see that the two wire connected to the coil lead is not linked to any other pole in the relay. It's just connected to the relay coil alone. A ti rí wípé wáyà yìí kò fara kan àwọn conductor tó kù nínú relay. So ẹ jẹ́ ká tò relay yìí pọ̀ padà. So now let us put back the tension spring. This is the tension spring. So basically our relay is well assembled back again. So as you can see, these two conductors will be the one that will be connected to this storage device. So now let us connect. We will now connect our transformer to the two pole in this side. So the relay coil, we want to use external current. There is a supply through this cable. There is a 220 volt supply through this cable. Is AC current coming from another source. You can see 196 to 200 volts. So basically we want to use this supply just to energize this relay coil alone. You can see only the two cable going to the relay coil is connected to it. You can hear the reaction. The pole is vibrating, is acting as electric switch. You can see it's vibrating, so it's acting as electric switch, so representing the function of MOSFET. So now our relay is being connected, is being prepared to act as our MOSFET. So now let us connect this transformer to the two pin that I told you we are going to connect it to. So now you can see this is our bulb, and you can see now let's connect it to the supply. You can see immediately I remove it from the battery, you see it goes off. You see now it's on now. So to balance the frequency of this bulb, for the bulb not to shake like that again, there is a capacitor that I will add that will make the frequency of the bulb stable, or to increase the wave of the relay. Basically, this relay has been used to replace MOSFET, and this is our own mechanical inverter that you are looking at in the video. So as I remove it, you see that the light goes off. As I put it, you see that the light come back. So now let me connect it permanent. You can see 12 volts come from this battery, enter into the relay pin. The relay pin vibrates from here. So from these two poles here, it has become alternating current. Due to the wave, it has become the current that goes in sinusoidal wave. The current flow in alternating way. The currents keep on alternating before coming to the primary winding of this transformer, in which the primary coil of this transformer accepts it as AC current and send it to the secondary winding of this transformer, in which the secondary winding step it up before showing in the bulb. So now, ladies and gentlemen, let us check it. You can see the meter has already been set in AC side. So let us read the voltage. Something is wrong with this meter. I'm unable to use this meter to read the voltage. The voltage coming to this bulb is 220 volts. That's why the voltage can make this bulb to power on. So let us use another bulb. So this is another bulb. Okay. You can see there.